Hello, we are going over the sum and difference identities today. So you have the list of sum and difference identities listed up here. You can refer back to these as I'm going over the problems. And so we're going to start here with number 1A. We are finding the exact value of each of these. Now the problem with 75 degrees is 75 degrees is not on the unit circle, so you can't just find the exact value using the unit circle. And remember, we want exact value, which means you can't just type this into your calculator and see what the decimal version is. We want the exact value. So this is where our identities come into play. What we want to do is think of two numbers that are on the unit circle, two angles, that will either add or subtract to give us 75. So in this case, I could use 45 plus 30. They're both each on the unit circle. And this allows me to now use the sum formula of cosine because that's a plus and this is cosine. So I'm going to, I have it listed right here. I'm going to jump over to this identity, and this is what I'm going to use and start plugging into. Because I said I'm going to use 45 plus 30, this means that whenever I see an A, I'm going to replace it with 45. So I'm going to have cosine of 45 and sine of 45 there. And whenever I see a B, I'm going to replace it with a 30. So when I write this out, I'm going to have cosine of 45 times cosine of 30 plus sine of 45 times sine of 30. And what this means is that now I have these values that I can find on the unit circle. Cosine of 45 on the unit circle will give me root 2. Cosine of 30 would equal root 3 over 2. Let me close this out and maybe just zoom in here. Sine of 45 is going to equal root 2 over 2. Oh, sorry, I just realized I made a mistake here. Remember, Cosette thinks their signs are opposite, so the formula or the equation here should be opposite sign. Sorry, I wrote that wrong. Okay, sine of 30 on the unit circle gives us 1/2. So from here, all you have to do is simplify. Root 2 times root 3 is going to equal root 6. 2 times 2 is 4. And then we've got root 2 times 1. That's going to equal root 2. 2 times 2 is 4. Now from here, we can just combine these. We have the same denominator of 4, so that becomes our common denominator. And because we can't add or subtract roots, this will stay root 6 minus root 2 all over 4. Alright, for our next problem, we have tangent of 15 degrees. Now again, 15 degrees is not on the unit circle, so we have to think of two angles that are on the unit circle that will add or subtract to give us 15. So right away, I can think 45 minus 30, that gives us 15, so that's going to work. Now, this, since we did minus and we have a tangent here, I'm going to go up to my list of identities and I am going to use this identity right here because I have 45 minus 30, so now whenever I have an A, I'm going to replace that with 45. Whenever I have a B, that gets replaced with 30. So I'm going to plug that in to these parts right there. coming back down here. I'm going to have tangent 45 minus tangent 30 all over 1 plus tangent 45 times tangent 30. Now we all love tangent because when we find it on the unit circle, you have to take the y value, divide it by the x value, or take that y value and multiply it by the reciprocal of the x coordinate. So when we do that, we will get 1 minus root 3 over 3, because tangent of 45 degrees is equal to 1, tangent of 30 is equal to root 3 over 3. We've got 1 from the actual identity, and then tangent of 45 is 1. We already figured that out. And tangent of 30 is root 3 over 3. From here, we've got to work towards simplifying. So the first thing that I see is this 1 times root 3 over 3. I'm just going to go ahead and change that to root 3 over 3. And the next thing that I need to do is start to combine these two fractions. So 1 minus root 3 over 3, I'm going to change this 1 to have a common denominator, so I can multiply it by 3 over 3 to get that common denominator, and the same thing is going to happen at the bottom. So that now that I have a common denominator, these will become just one fraction at the top, one fraction at the bottom. This is kind of like my main fraction bar. And so what I will do is I will take the numerator and multiply it by the reciprocal of the denominator. We all know that trick when you're dividing fractions. And I will cross cancel those 3's, and I'm left with 3 minus root 3 all over 3 plus root 3. These are not going to cancel or simplify because they're being added and subtracted together. If they were multiplying, then we could simplify, but addition doesn't allow us to do that. So that is going to be our final solution for the tangent problem. And I'm going to switch over a different color here. For our next problem, sine of 165. So we can probably think of a couple of different combinations. I could do 120 plus 45. That would give us 165. I could do 210 minus 45. That could work. As long as they're both on the unit circle, I could do 135 plus 30. That could work as well. I'm going to go ahead and stick with this one. Let's try a subtraction problem here. So this is going to turn it into sine of 210 minus 45, which means I'm going to use the difference identity for sine, because this one has the minus here. So I'm going to use this identity, which will turn this into sine of 210 times cosine of 45 minus cosine of 210 times sine of 45. This is where the order really does count, because it's subtraction, right? So it's 210 minus 45. So that means anytime you have an A, it's going to be 210, and the B becomes 45. Okay. And once that's done, we go to the unit circle. So sine of 210, that's going to equal negative 1/2. Cosine of 45 is root 2 over 2. Cosine of 210 is root 3 over 2. Sorry, negative root 3 over 2. Don't want to forget that negative there. And sine of 45 is root 2 over 2. So multiplying, we have negative 1 times root 2, that's going to be negative root 2. And 2 times 2 is 4. These two negatives here are going to turn this into a positive. So we have plus root 6 over 4. And I will combine this into a fraction, so it'll become negative root 2 plus root 6 all over 4. Sometimes we don't like to have this negative out in front, so we can switch the order of addition and just turn this into root 6 minus root 2, as long as the signs stay the same. So the root 6 is still positive, and the root 2 is still negative. So that will be our final answer. The next problem, write the expression as a single sine, cosine, or tangent. So this is the identity all expanded. So we have to determine whether this is a sine or cosine identity. And because I see that these are alternating sine, cosine, cosine, sine, I know that this is one of my sine identities. And these always stay in order. So I know my A is going to be 40 and my B is 12. And if this is a minus, let's take a look at these sine identities here. A minus here means that it is subtraction in the middle here. So I know that this will become 40 minus 12, and this is equal to 28 degrees. So that's our final answer. We're basically just working backwards. So we have the expanded identity. We need to figure out which function it's for. So this one I see it's cosine, cosine, sine, sine. So I know this is a cosine identity. And we have 50 and 15. A plus in the middle of cosine. I know cosine is opposite signs, so a plus means that this will be a minus. So we have cosine 50 minus 15. That's going to equal cosine 35 degrees. Last one, this one obviously is a tangent identity. We just have to figure out which one it is. And the easiest way to know is the top symbol here. It's a minus. So if we go back up here, minus means minus. Easy as that. The order of the angles always stays the same. So 225 is going to be your A, and then minus 86, which will give us tangent of 139 degrees. Okay. So that's how you write the expression as a single sine, cosine, or tangent of a single angle. Here we're verifying the identity. So what that means is we need to get one side to look like the other side. This is our simplified side, so I'm going to work on this side and try to simplify it to look like what I have over here. And so what I notice is that we have addition inside of cosine and subtraction inside of cosine. So these are actually two separate identities that I'm going to expand. So this first one, let's do this in different colors here. The first one that I'm going to expand will become cosine x cosine y minus sine x sine y. We're taking this addition of cosine and expanding it all the way through. Now I'm going to add because I have this addition sign here, the next identity, which will be cosine x cosine y plus sine x sine y. And now I've just expanded this whole thing, and we can try to simplify. So I'm looking for common terms. I see this minus sine xy plus sine x sine y. Those are just going to subtract and become 0. And now I'm adding cosine x cosine y plus cosine x cosine y. So that'll become 2 cosine x cosine y. And look at what we wanted to prove. Now that is verified. For the next one, we have cosine pi over 2 minus x equal to sine x. So this is obviously the more simplified side, so we're going to keep that side the same, and we're going to work over here. Since I see subtraction inside of the cosine, I'm going to break this down. Cosine pi over 2 cosine x plus sine pi over 2 sine x. So we're just using the identity for subtraction of cosine. And what I see here now, this and this both have an angle, the angle is pi over 2, plugged into it. So I can find the exact value of both of these. The exact value of cosine of pi over 2, if I look on the unit circle, is going to equal 0. I can't figure out cosine x because x is unknown. Sine of pi over 2, if I look on the unit circle, is 1. Again, sine x, I can't determine what that is. But now anything times 0 is 0. 1 times sine x is equal to sine x, and now this is proven.